Hi everyone, welcome back to Spratt Stem Academy. This is SAT Saturday number 5. We're going to be going through questions 13 through 15 on the SAT No Calculator section of practice test number 10. Let's get into number 13. In the xy plane, the graph of the function f of x equals x squared plus 5x plus 4 has two x-intercepts. What is the distance between the x-intercepts? If you look here, you see that we have a quadratic equation, which means that if we were to draw this out on a graph, and this isn't going to be a perfect depiction of this function, we would have something that looks like this. X-intercepts are going to be points of the function that touch the x-axis. So in this case, we are going to have, here's one x-intercept and here's another x-intercept. So we need to figure out what our x-intercepts are for this function. So let's write down our goal. Our goal is to write x-intercepts. But they also want to know what the distance is between the x-intercepts, so how much space is in between them. The easiest way to do this is to factor your quadratic function. Since you already have the full function, we can just factor this to see our zeros or our x-intercepts more clearly. So when you factor a quadratic, you're going to have two parentheticals. And if you remember from a previous video, when you factor, you basically have to find two numbers that multiply together to give you C and add or subtract together to give you B, which is the 5, and then C is the 4. So in this case, I'm going to use 4 and 1 because we know that 4 times 1 equals 4, and we also know that 4 plus 1 equals 5. So these numbers work, but we have to watch our signs. We don't want to say -4 times -1 because yes, it would give us +4 when multiplied together, but if we were to take -4 minus 1, we would get -5 instead of the +5 that we want. So I'm going to change these to both be positive. Now we have 4 times 1 equals 4, and +4 plus +1 equals 5. And so this is how we factored out our quadratic function. And these right here are going to tell us what our x-intercepts are. We simply set both of these equal to 0 and solve for x. For this top one, when we solve for x, we end up getting -4, and when we solve here, we end up getting -1. So our x-intercepts are going to be -4, 0, and -1, 0. I've just kind of written them as coordinate points. Now we want to note the distance between them. So let's imagine that we have a number line. And here's 0, -1, -2, -3, -4, 1, 2. If our first x-intercept is -4, and our second one is -1, we need to find this distance between them. The easiest way to do that is just count your spaces. 1, 2, 3. That's 3 spaces, so we know that the distance between them is 3. So choose answer choice C, 3 units. That's how you do number 13. Let's go to 14. What are values of x that satisfy the given equation? Here we're given an equation here, and we need to solve for x to see what satisfies and makes the equation true. So the easiest way to do this is you can solve for x on your own and do your whole calculation, but since they've already given us values, we're just going to plug them into the function and see what works. This is just kind of a time saver for when you're taking the exam. So let's start with the first value, 1. If we plug in 1 for x, we're going to get square root of 4 times 1 equals 1 minus 3. And so that was square root of 4 equals -2. And we know that this statement here, this is not true because you cannot have a negative number come from a square root. So we know that 1 is not going to satisfy the equation. Let's try 9, our second value. 4 times 9 equals 9 minus 3. So 4 times 9 is 36, and 9 minus 3 is 6, and the square root of 36 is 6. 6 equals 6. That is true, which means that this value does satisfy the equation. So the correct answer choice would be 2 only. Number 15 is our last question. Let's read it. In the system of equations above, A is a constant. For which of the following values of A does the system have no solution? So I'm going to highlight no solution. So we have a system of equations here, right? What we want to do is first recognize what each equation is. Well, actually, first let's write down our goal. If you look at these equations, you notice that they are both linear, which means they have the format of y equals mx plus b, meaning that each one has a slope and a y-intercept. So if we know this, that means that we can sort of rewrite these and make them kind of more clear for us. So I'm going to rewrite negative 3x plus y equals 6 as y equals positive 3x plus 6. And I'm going to rewrite ax plus 2y equals 4 as 2y equals negative ax plus 4. But this simplifies, if we divide everything by 2, this simplifies down to negative ax over 2 plus 2. Okay, so I'm going to erase this now. And these are our two equations. Now, here's something you need to know about slope. If you have the same slope for two lines, those lines are going to be parallel. They're never ever going to touch. So that means that they will not have a solution. So no solutions. If your slopes are reciprocals of each other, so like they're opposites of each other, that means you have perpendicular lines, which will give you solution. You will get one solution because they're going to meet up at a point. And when lines meet up at a point, that is when you're going to have a solution. So in this case, they want to know what value of A is going to give you parallel lines or no solutions. So essentially, they're asking which of these values here, when plugged into this equation, gives you the same slope as the other one, so as this one up here, because that would give you no solutions. They would be parallel lines, never ever touching, never meeting to make a solution. So I'm going to move this up here. We know that background information now. So we need to plug in one of these numbers into our A value and see if this gives us the same slope as this, 3. So we want a slope of 3. So which of the values is going to give us a slope of 3? Let's plug in some numbers. If we plug in negative 6 into our A to be our A, we get y equals negative 6x over 2 plus 2. This simplifies down to 6 over 2x plus 2, which further simplifies down to y equals 3x plus 2. And this slope is in fact the same as the slope on the top equation, which means that these would be parallel lines. They would never ever touch. I'll just show you. They would on a graph, they would probably look like something like this. They'll never touch. So no solutions, which means answer choice A is correct. And so we immediately know that A is correct because the other ones would give us either a negative slope or a slope of 3 over 2. So that is how you do question 15. I hope this all made sense and I hope you enjoyed. Don't forget to like, comment, and subscribe for more.